Okay guys, what we're going to be starting today is a lesson on finding the total surface area of a 3D figure. Okay, so first of all, when we talk about surface area, what are the units we're going to talk about? Well, in surface area, basically it's always units squared, and the reason is we want to talk about something covering the object completely. You need to have units squared because you can imagine anything that's covered in a 3D image could use little tiny squares to cover it, and that's kind of the best way to think about it is to cover something takes squares, to fill something takes cubes. So like I said, imagine wrapping a present where there's absolutely no overlap. The paper goes perfectly edge to edge, and there's no pieces showing. That's kind of what total surface area is. It's the amount of wrapping paper, for example, it would take to cover every single bit of the box without any overlapping. Okay, so in geometry we have two types of three-dimensional polygon-based figures. And by that I want to emphasize the word polygon. So these are called polyhedra or polyhedron. What a polygon is anything that has straight lines connected by vertices, which are corners basically. So for example, the ones that you're familiar with are probably like a rectangle, a square, a triangle, trapezoid, parallelogram, and those are the most common ones, but also even like hexagons, octagons, things like that. Those are all polygons because they have basically what amounts to a straight line and another straight line, and then there's that vertice in the center. So if you think about it sort of like, hey, everything's that. Well, circles are the things that are not polygons. So we'll talk separately about how you find the surface area of something that is a circle based, but today we're talking about the two major kinds of, actually the two only kinds that we're going to ever talk about, three-dimensional polygon-based figures, which are called polyhedra. So the first one is a prism. A prism consists of two identical polygon bases, so again, rectangle, square, something like that, connected by straight lines. So looking at this one here, boxes are unusual because they can have lots of, you could count almost anything as a base, but in this case I'm going to count the front as the base. What you'll notice is on the back there's an identical base that's the same, and they are connected by straight lines. Most of the time, they don't draw the see-through image where you see all those extra lines. It helps some people, though, to go ahead and take a second and just kind of draw those lines in. And usually what we do in that case is we sort of make them dotted. Erase a little smaller here. We make them dotted. And that helps some people to visualize them better. But you don't have to do that. You don't have to draw that in. But if it helps you to visualize it, go ahead and do that. So looking at another example, this is a triangle-based prism. The last one was a rectangle base. It could have been a square, but we wouldn't know for sure unless we knew the sides, because remember, in geometry, don't assume. So in this case, you can see I've got my triangle base there. I would have an identical triangle base at the back. Here, I've got looks to be a septagon base, and you'd have the same at the back. A lot of times people get confused and think that this right here is their base, but remember there's not an identical one there connected by straight lines. Okay, that's what would have to occur in order for that to be considered a possible base. Okay, the other time we're going to talk about is polygon-based pyramid. So again, emphasizing the word polygon means the base is going to be a square, a rectangle, a triangle, something like that. And in fact, really what happens is because pyramids have to have special properties in that all the sides have to be the same and the height has to be in the dead center of the pyramid, you really only have a few kinds of pyramids, which are ones that have square bases, equilateral triangle bases, or something like could be like a hexagon and such. But the only one that you can actually figure out the area of yourself is a square-based pyramid, because everything else you don't have the tools yet to calculate the area of it. So as I said before, it has a polygon base, but what's special about a pyramid is instead of having two identical bases connected by straight lines, pyramids come to a point. So for example, you have your base down there, but at the top, as you notice, it comes to a point. Okay, some of the pieces that are important information when you do this is, like I said before, you've got your base down here, which is most likely going to be a square. You've got what we call the slant height, which is the direction from the point to the edge. And then you're also often going to need the height of the actual pyramid itself. Okay, and that's the height h. A lot of times they won't give you that, or they won't give you the slant height, but what you got to remember is this is my height, this is my slant height, and this would be equal to half of the base because it's cut in half. So as you could see, with that being a right triangle, you could find either of those missing sides using the Pythagorean theorem, and later on we'll be needing to use that information. So let's go ahead and take a look at this shape as an example. What we're going to be doing is we're trying to figure out how much it would take to cover each of the sides with, imagine paper, like we're wrapping this box for present, birthday or something. So we're trying to take each of the sides and completely cover it in paper. So the best thing to do first is to determine how many faces there are. When we talk about faces, those are the parts of the box that we can see and cannot see. We try to avoid calling them sides because sides are straight lines in general. So what we're talking about here is faces. How many different faces are there? Well, I can see 1, 2, 3 faces. However, I know there are ones I can't see. For example, on the bottom, I can't see the 4th one. Back here, I can't see the 5th one. And then back here, I can't see the 6th one. So altogether, there are 6 faces. This is where spatial visualization comes into play because you are going to be needing to be able to do stuff like this. So the first step, decide the number of faces. In this case, 6. The reason that's so important is it tells us how many things we should be adding. If, for example, we realize we're only adding 5 things, we forgot something. So now my best strategy for this is to actually draw out the different faces. I think that really helps, and make sure you don't forget anything. So in this case, I have a square in the front. I have the exact same square in the back. I have the rectangle on the side and an identical one behind it. I have the rectangle on top and an identical one on the bottom. Now, one thing I did rather quickly on this was I just wrote it with all the numbers on there. So one thing that helps some people if you struggle with this is we know that for squares all the sides are going to be the same. We also know that the sides are the same at the top, across, and these back here would have to be 4 as well, and 4 on the bottom. And that might be enough to help you get started, just maybe transferring straight up and straight over those sides. Because, they have to be the same, otherwise it wouldn't be a box, it would be sort of a dented looking box. Okay, now that we have all those sides, what we're going to do is we're going to figure out the area of each one. 4 times 4 is 16. 4 times 8 is 32. 4 times 8 is 32. And that gets us where we're going to be. Now we're going to go ahead and simply add up all the areas. 16 plus 16 plus 32 plus 32, 4 times. Now notice, I'm going to count. I have a total of 6 objects. That's important because that matches up to our original faces. If we're missing any of that, then that'll tell us we forgot a face of the figure. Add that up, you get a total of 160 units squared. Notice that I write units squared every single time because I don't want to forget to. Definitely you will have the problem marked wrong if you have the incorrect units. For example, you just have units, not units squared, or units to the 3rd power instead of units by itself, units squared. Then you will definitely get the problem marked wrong. So let's take a second and try this one on our own. The base here is going to be that triangle. Now remember, for area of a triangle, you're going to be using base 1 plus base 2, which is 0, times height, divided by 2. So base 1 plus base 2 times height divided by 2. Remember again that base 2 on a triangle is 0. So go ahead and pause the video, see how far you can get. Remember, start off with how many faces does it have, and make sure you map that out, and then try to find the area of each one. So pause the video, give it a try, hit play when you're ready. Okay, so starting off here, we have 5 faces. Again, remember, if you can't see them, you've got 1, an identical one back here, 3, 4, and 5. Another way I like to look at it is if I think about the triangle, I'm going to get 1 and 2 just from that triangle alone, and then I'm going to have a base that goes with each of those sides. So that's going to be 3, 4, and 5. And that's just because of the fact that each of them has to have a face attached to it in order to, actually create the polyhedra. All right, so now we're going to draw them out. We have 2 triangles. The rectangle that you see on right there. And the bottom. Okay, one of the keys here, some of you might have gotten stuck at this step right here. You need to always be able to find the sides, because if you don't know that side, then you would only have this piece of information that was a 10. And a lot of times people say, oh, I can't solve this problem. Well, if I give you a right triangle in geometry, I'm going to assume you can do the Pythagorean theorem. That's really an important concept. You should have learned it in pre-algebra. You should have learned it in algebra. So definitely in geometry, and we did it again in geometry, you definitely should be able to do this. So it's imperative that you think, okay, right triangle, missing side, Pythagorean theorem. Also, I taught you guys that a 3, 4, 5 right triangle is a special kind of right triangle, so you may have been able to get the answer just noticing that there was a 3 and a 4. Remember, the next step is to calculate each area. Base 1 plus base 2, so 4. So looking at the triangle, base 1 is 4, base 2 is 0, so that's 4 times the height divided by 2, which is equal to 6. Same thing on the bottom one. And the areas are 50, 30, and 40. Remember, for rectangles, you just multiply base times height. Adding those up, I get 6 plus 6 plus 50 plus 30 plus 40, which adds up to 132 units squared. Again, right units squared every time you talk about area, that way you don't forget it. Okay, next we're going to look at a pyramid. Now, when you're given a pyramid, like I said, you have 2 choices. You either have a square-based pyramid that you can actually calculate the area, or you pretty much have any other shape, and in that case, I'm going to have to help you guys figure out the area. So first of all, let's think about how many faces we have here. So take a second to think about that. Okay, if you think about it, it's kind of the same as what we did before. All we really lose is the second base. So we have our base on the bottom, which is number 1. And then you have 2, 3, 4, and 5. But using the logic that I talked about before with the square, instead of getting 1 and 2 this time, we're only getting 1. But then we still have 2, 3, 4, and 5 to go with it. And that might help you if you're having a hard time picturing this. It's remember the base has to have a side connected to each of them, a face. And then in addition to that, you either have 1 of the base or you have 2 of the bases. All right, so now we're going to go ahead and map them out. We have a 9 by 9 square. And what ends up happening that's kind of nice is every single side of the pyramid actually is identical. And that's because of the fact that we have a base that is either a square or an equilateral triangle or some sort of shape that has all the same sides. It's very important because otherwise that number 12 slant height, it wouldn't be the same for all of them. So it's really going to work out this way every single time. So as long as you can remember that, it's not too hard to find the surface area of a pyramid. So now we're going to look at our areas. This is 81, 9 times 9. All the other ones are going to be 9 plus 0, which is 9, times 12, which is 108, and then divided by 2. So remember, again, I'm using the formula base 1 plus base 2 times height divided by 2. And in this case, my base 1 is 9, my base 2 is 0, my height is 12. So that gives me an area of 54. And the last step is to add them all up. 81 plus 12 plus 12 plus 12 plus 12 is 128 units squared. So make sure these notes are complete, and then I'm going to go ahead and give you an example to try on your own. I'm going to give you a square base pyramid, sides of 4. I'm going to give you a slant height on there. Of 10. And an actual height of about 9. One of these pieces of information you will not need, which is the actual height. But I want you to see that a lot of times problems will give you all the pieces, and you have to pick out what's important. So try to pause a video. Remember, you want to start off on a polygon one by numbering the faces, and then try to go ahead and figure out this example. Okay, so hopefully you pause the video to do that. If not, pause it now, because I'm about to go over the answer. Alright, so thinking about it here, we have our square base that's on the bottom. Okay, with that, we're going to end up with 1, 2, 3, 4 triangles. Okay, and each of those triangles has a height of 10 and a base of 4. Each one does. So using my formula, base 1, 4, base 2, 0. Okay, so 4 times height, which is 10, 40, divided by 2. So 40 divided by 2 is 20. And remember, each one of these would equal 20 units squared. Okay, over here, 4 times 4 gives me 16 units squared, and I can now calculate my total area. Which is 96 units squared. Okay, so hopefully you're able to figure that one out. If not, maybe you might want to watch back through the example again or go back to the original example. Okay, so now what we're going to do is we're going to look at the 3 major non-polygon shapes. So what that means is things that have circles involved, because anything that's basically not a polygon is a circle. We could have ovals and stuff like that, but we don't have the formula to figure out the area of an oval. So if you see something that's going to be a circle, it's pretty much got to be a circle. It's good to ask because in geometry we don't make assumptions, but in this case we really have no way to figure out anything unless it's given to you or it's a circle. So starting off, we're going to start off with a sphere. Sphere is kind of unique. In the real world, you see spheres in like basketball, soccer ball, baseball. It's also in food. It's a very efficient use of volume, which is why I think a lot of times in nature these things occur. However, I don't have the answer to that, but it is an efficient use of volume. So you'll see it like in an orange, as an example of a sphere. Certain other objects come up that have a spherical shape. And obviously planets do too, which I think has to do with the pull of gravity. We need to find a formula for the surface area because there's no easy way to calculate it. You know the area of a circle is pi r squared, and you can think of it as a sphere is making 4 circles altogether because that's really what it is. But the formula is 4 pi r squared. And really for all of these non-polygon shapes, I will be giving you the formula. However, I do want you to kind of understand where it comes from. So in this case, I would want you to say it's, the surface area of sphere is sort of like 4 circles put together. Okay, the next example we're going to talk about is, let's do an example of a sphere. Okay, so remember we're going to use the formula. The formula is given 4 pi r squared, and this is the way it would be given on a test. So go ahead and pause the video and see if you can calculate the total area. Okay, so total surface area, we use that formula. All we have to do is take that 4 and plug it in. So now I'm going to get from here, 4 times 4 is 16. And 4 times 16 is 64 pi units squared. So spheres tend to be pretty simple. But you definitely want to use the formula and make sure you know what to put where. So trying that again, give you a different one to try. Okay, so we'll say that it is 10 this time. And remember your formula, so I'll give it to you since you'll always be given it, is 4 pi r squared. So go ahead and pause the video, give that one a try, hit play when you're ready. Alright, so again, all we're doing is we're substituting in my radius of 10. 10 times 10 is 100. And 100 times 4 is 400 pi units squared. As you can see, a sphere is really an efficient use of space with only, for example, let's say it was 10 feet across. If I made a sphere that was 10 feet radius, which would be 20 feet, if you count the whole direction across, it'd be 20 feet across. It's not a huge figure. It could fit inside most rooms, but it would actually have 400 times 3.14, so it would have around, it would be able to hold around, it would take 1,200 square feet to cover it, which is huge. So that's a lot of area. So next we're going to talk about a cylinder. A cylinder is, in the real world, a cylinder is basically like a can. Some buildings are built that way. The purpose of a cylinder is that it, in terms of buildings, is that the air moves past it easily. And again, it's going to be an efficient use of volume and surface area, because if you remember back to when we found the area of the different shapes given a perimeter 400 for that project, we found that the circle actually gave you the largest area given the same amount of distance around the shape. So it's a very useful shape for things like surface area and volume. So here it's best to break it down and understand the formula. I'm going to give you the formula, however, I want you to understand where it comes from. So first of all, you have a circle. This could be the top or the bottom, so you have two identical circles. In addition to that, you have that sort of curved piece around. Well, if you were to cut a can, for example, cut the top and bottom off of it, and then just cut straight up the side, what you'd notice is it actually is a folded or sort of a rolled rectangle. So the question is, what are the area of these rectangles? Well, the bottom one's pretty simple. Okay, the circle is pretty simple. Every circle has an area of pi r squared. So those are pretty simple. So as you can see, if we were to add those together, at the current point we have 2 pi r squareds. Okay. Now the other one is a little bit more complicated. What we have here is, if you think about it, this length right here is actually, when I cut it, the distance around the circle. Because if I cut down the side right here, for example, and unfold it, that distance across the top is going to be that whole distance that was around the circle. So that actually ends up being the circumference of a circle, which is 2 pi times the radius. So that's actually the circumference of a circle. Now the height is simply the height right there. So when I multiply 2 pi r times h, I'm just going to get simply 2 pi r h. So that's where that's coming from. So when we look at this overall formula, like I said, you're going to be given the formula. But what I want you to understand is, where does each piece come from? This comes from the top and the bottom. Okay, you got the bottom circle and the top circle. This is the rectangular part. The reason I say that is, what if I gave you an example where you had to find the surface area, but you didn't have to find this piece, like this was a hole, okay, like an open can? Well, then your formula is going to change. You don't have 2 circles to worry about. You only have 1. So then your formula now, you take away one of the pi r squareds. Or you could be that you don't have either of those circles, in which case the formula is just 2 pi r h. I want you to understand where the formula comes from enough that you can piece by piece know what each piece of it means. You're not going to have to memorize the formula itself, but when you look at it, I want you to think, oh, okay, this right here is the rectangle part, the part around. That's this piece here. Okay, and then this is one circle and the other circle. And then that'll be enough that'll help you really understand it. Okay, so this example could have a radius of, let's say, 3 and a height of 6, and that's very common. Remember, the formula is going to be given to you. 2 pi r squared, that counts the top and bottom, plus the area around, which is 2 pi r h. So again, use the formula correctly, make sure you understand where everything's coming from, and we'll go from there. Okay, so again, we're just using the formula. So it's going to be 2 pi, radius is 3, squared, plus 2 pi, radius is 3, height is 6. Now we just simplify. 3 times 3 is 9. 9 times 2 is 18 pi. 2 times 3 here is 18. 3 times 6 is 18. And 2 times 18 is 36 pi. When you add that all together, you're going to end up with 54 pi units squared. Okay? So simple as that. We're going to try one more together. This time, though, I'm going to give you a cylinder with radius of 8 and a height of 4. However, this is an open can, which means I don't need to include the area of the top. I only need to include the surface area of the bottom. Remember, your normal formula is 2 pi r squared plus 2 pi r h. So think about how you would modify this formula for this situation. Then go ahead and solve the problem. All right, so hopefully what you thought of was I only have one circle, so I'm getting rid of one of my 2 circles. So that should be the formula you use. If you didn't get that, you're going to need to pause it, erase it, and redo the problem. Okay, so using this formula, I know my radius is 8. And my height is 4. Okay, simplifying, this makes 32. 32 times 2 is 64 pi. Over here, 8 times 8 is 64. So I end up with 64 plus 64, which is 128 pi units squared. We always use units squared because we're talking about area. Okay, last one we're going to talk about is a cone, which is really a lot like a pyramid, really. It has a base that's a circle, and it comes to a point. So the real world cones are used in many ways, such as funnels. And even in architecture, again, nose of an airplane. They're a very good, useful way to distribute something across it. And then as well, like in a funnel, you can pour a lot of stuff in there, and it kind of focuses it and gets it to a point. So they're pretty useful in the real world. And there are instances where you would have to figure out the volume and surface area of one. So as you can see, this is a little different. We actually have 3 numbers that we have to have for this problem. We have to have the height, we have to have the slant height, and we have to have the radius. Now that doesn't mean we're going to use all 3 of them for this, but those are all important information, pieces of information when we do problems of volume and surface area. Remember, when you go back to cone, we had the same things. Instead of a radius, we had basically what amounted to halfway across the square or halfway across whatever shape we have. Again, we're going to use a formula, but I want you to be able to tell me where the pieces come from. So, first of all, we have a circle. That circle represents the bottom, right there. Okay, so when we talk about that, that's going to be normal circle area, which is pi r squared. We also have this sort of odd shape here. It looks like a Pac-Man, right? Well, what it is if you actually take the cone piece and sort of cut it and open it, you're going to notice it's not quite a whole circle, but it is in fact sort of like a piece of a circle. Now, without knowing that central angle, we really can't figure out that margin of the circle, that piece of the circle. Remember, the area of a circle segment was, or a sector was, dividing that 360 by that angle. So if I'm not given that angle, I really have no way of figuring it out at this point in geometry. So what happens is this is pi r squared because it's the area of a circle, and the other one ends up being pi rs, which is kind of odd, but it may not be logical why that works out that way. I actually, I can't, visualize in my brain why that works. But what I'm looking for you to remember is, okay, when you look at this, one of those is the area of a circle. Pi r squared is always the area of a circle. So think, what part of this shape is a circle? The bottom, okay? And then the pi rs is the cone piece. So for example, if this was attached to something, you wouldn't have to figure out the area of the bottom. That would not be part of it. But you would need to find the area of the cone, so you wouldn't ignore this piece and simply go with pi rs. All right, the last kind of practice problem we'll do is a cone. I like to kind of draw like an oval and then connect it. That to me is the easiest way to draw a cone. You need two pieces of information from me at least. I will give you the slant height is 9. And the radius is 4. And that's all the information you need to be able to do this problem. Because the formula calls for pi r squared, that's the bottom, plus pi rh, that's the weird sort of cone Pac-Man shape. Okay, going ahead and figuring it out now. Pause the video, give it a try. Okay, so plugging it in, we're going to get pi times 4 is my radius squared, plus pi times 4 times the slant height. Sorry, the formula is actually S. Okay, times the slant height, which is 9. Multiplying that out, you're going to get 36 pi here, plus 16 pi, which ends up being 52 pi units squared. Okay, so we'll try one more example. Again, start with the oval. Connect it. All right, so this time I will tell you that the radius is 3. The height is 4, but we don't actually know what S is. So again, the formula is pi r squared. Remember, this is a right triangle. That should be a hint. Plus pi rs. So go ahead and pause the video. Give it a try. If you can't figure out S, that'll be the first thing I do, and you can go from there. Okay, so because we're talking about a right triangle, Pythagorean theorem applies. So we end up with a 3, 4, 5 right triangle. If you don't remember, Pythagorean theorem is leg squared plus leg squared equals hypotenuse squared. The S we didn't know. You're going to get 16 plus 9. So 25 equals S squared. So therefore 5 equals S. And we all practiced these in class and were able to do them. So now I'm going to backtrack a bit here. Okay, so now what we're going to do is we're going to go ahead and plug in our different values. So we're going to get pi r is 3 squared plus pi r is 3, s is 5. Very common mistake is to put a 4 right here. That will definitely mess you up. So now this is going to give you 15 pi. 3 times 3 is 9 pi, which makes 24 pi units squared. So hopefully those helped. Be able to watch those while you guys do practice problems. Remember, anything complex we do is simply going to be you're only looking at just the cone part or just the circle part, or you're doing half of a sphere. Something like that. Which, by the way, just to cover it, I do want you guys to be able to critical think, but if I only have half of a sphere and the radius is something like 4, the formula is not going to be half of 4 pi r squared, because when you cut this in half, you're actually making this something you can see now. So now you have an extra circle plus half of a sphere, which actually gives you 3 pi r squared. So you really need to kind of think about the pieces. Anything that's not a standard generic shape, you're going to have to think about what pieces are covered, what pieces aren't covered. And that's really part of geometry. It's part of, applying your thinking to something beyond the simple, easy example that you can see. So fill out the form below, if there's one down below there. Like I said, I hope this helps you guys do the practice problems and the homework.